Many firefighters have been taught that all hose streams can push fire. Therefore, you must always fight fire from the unburned side. Some firefighters have even experienced fire being pushed on them. But what does pushing fire mean? Pushing fire: when fuel gases hot enough to burn are displaced or pushed by pressure from an oxygen-limited fire compartment to a space with oxygen that mixes with the hot fuel gases and results in combustion. What conditions do you need to push fire? Well, typically you need a ventilation-controlled fire in a flow path that has intake and exhaust vents. Then you need a pressure source to create the push. In addition, you need an area on the low pressure side that has oxygen available for combustion. If you do not have these conditions, you cannot push fire. The pressure source could be from the wind, a fan, a fog stream, or a solid stream on a hand line that's being whipped around. If you review our research studies, we've conducted studies with each of these sources of pressure, and you'll see that even a small increase in pressure can drive hot fire gases through a space at speeds ranging from 6 miles an hour to greater than 20 miles per hour. There are situations where firefighters may want to use this push to their advantage when fighting a fire. Working with ISFSI and the Spartanburg Fire Department, we set up some tests to demonstrate pushing fire and also to show how it is important to choose your hose stream wisely and use it effectively for times when you want to avoid the push, the buildup of pressure. This video shows a post-flashover room fire in the rear of the structure. The rear room window is serving as both an intake and an exhaust vent for the fire room. The middle room is connected to the fire room by an open doorway. The middle room is also serving as an exhaust-only vent because the windowsill height is above the neutral plane. Note that the exhaust gases have enough heat and fuel to burn, but they don't mix with enough oxygen to burn until they are above the eave line. The fog stream is going to minimize the water entering the fire room, maximize the air entering the fire room, and provide the air pressure needed to push. Let's look at another experiment. Here we have two rooms on the second floor of a house. Both rooms are similar in size and had similar fuel loads, consisting of a wood bed frame, mattress, box spring, wood dresser, and pallets. The interior finish of the rooms in the connecting hallway at the top of the stairs consisted of wood paneling and oriented strand board on the walls, gypsum board and OSB on the ceiling, and wood flooring. The open doorways from each bedroom are opposite each other at the top of the stair. The doorway to the exterior at the bottom of the stairway is open. The cameras are located in this doorway looking up the stair. This door will serve as an air intake for the fire upstairs. The upstairs windows are the only point of exhaust initially in the fire, as the smoke building in the hallway does not have enough pressure to push all the way down the stairs against the intake flow of the air. The beds in both rooms were ignited at the same time and the fires began to develop. When both rooms had reached the fully developed fire stage, based on the available ventilation, gas temperatures near the ceiling were in excess of 1,000 degrees Fahrenheit. And the command to initiate water flow was issued. On the right-hand window, 150 gallon per minute straight stream was flowed. The straight stream was deflected off the ceiling to cool the gases in the room. The straight stream was then applied with minimal movement. This stream choice and nozzle handling technique maximized the amount of water entering the fire compartment, minimized the entrainment of air due to the hose stream, and kept the vent area of the window as open as possible to maintain the window as a low pressure exhaust vent. This allows combustion products and steam out of the window even though the line is flowing. The result? Little to no impact on the fire in the hallway at the top of the stairs, and a temperature decrease from the peak temperature at the ceiling in the right room from approximately 1,000 degrees Fahrenheit down to 300 degrees Fahrenheit. Next, a 150 gallon per minute fog stream, wide enough to cover the window, was flowed over the left-hand window on the second floor. The idea was to cover the vent, which minimized the amount of water that entered the fire compartment, and increase the amount of air that was entrained into the fire compartment, and increase the pressure at the window vent, thereby blocking the vent. Initially, this caused a surge of heated gases and smoke to be pushed down the stairs, as well as an increase in temperature in the fire compartment. As the fog nozzle was moved forward, more water began to enter the compartment and the temperature began to decrease. The fog stream created a higher pressure area at the window, effectively turning the exhaust vent into an intake. This added extra air for combustion, and it was an ineffective amount of water. In other words, not enough to cool the fire compartment, and therefore it converted to steam. This combination increased the pressure in the fire room and caused a quick burst of heat and flame to push down the stairs. When the fog stream was narrowed and moved forward, more water entered the fire compartment. The pressure at the window reduced. Cooling the fire reduced the pressure created by the fire itself and caused some of the fire gases to contract. As a result, the high pressure push stopped. So we've shown that you can push fire with a hose stream if the air from the stream creates a higher pressure area and the lower pressure area has oxygen available for combustion. However, we can also see that this can be prevented by the use of a solid or straight stream with limited movement if you're attacking from the exhaust side. If you're working in the interior and attacking toward the exhaust, you may want to use air pressure to your advantage to force heat away from your position and out another exhaust vent. Basically, it's all a battle of the pressures, pushing fire. When fuel gases hot enough to burn are displaced from an oxygen-limited compartment to a space with oxygen that mixes with the hot fuel gases and results in combustion. Please see our studies on ventilation, positive pressure ventilation, and fire attack so you can get a better understanding of the pressures created by a fire inside a structure, the impact of wind, the impact of fans, and the impact of hose streams, so you can make good choices on the fire ground.